Here we go again. We have another set of conceptual questions. So go ahead and answer, see what you think. All right, the correct answer is C. We know there is a force of tension upwards because it's connected to some sort of string, cable, something. We know there's a force of gravity downwards. Those are the only two forces acting on it. But because it is moving through this circular path, there is an acceleration, specifically the centripetal acceleration that points towards the center. So that means there has to be a net force that points towards the center, because the acceleration is always a result of having a net force. So the tension needs to be bigger than the force of gravity to have this book moving back and forth through a circular arc. If we were to write the equation that described the net force in that radial direction towards the center, we would say tension minus mg is equal to the mass times that centripetal acceleration. And then we could relate that to the speed by the v squared over r. Let's look at another one. So the correct answer here is E. This one's a little weird to comprehend. So roller coaster, like at Lagoon, if you live in Salt Lake or near Salt Lake, Colossus has the big two loops. So the roller coaster car is moving along. At some moment in time, it's up at the top, but it is upside down. We are assuming this is as drawn in the picture, in that it's just wheels on the track. Of course, there's safety features where oftentimes there's a contraption where that connects to the opposite side of the track. But as far as this picture is concerned, the track itself will be pushing downwards. A normal force. The surface will always push perpendicular to the surface. The force of gravity, of course, is downwards. It's those two together that are creating the centripetal acceleration. Oh, excuse me. So the normal force is not allowing that roller coaster car to continue in a straight line, to continue off and travel away from the roller coaster ride. All right, one more question for this video. Go ahead and determine what you think the answer is. Correct answer is A. So the car's been driving up, it's going to head back down. The fact that it is moving through some sort of circular path means there is a centripetal acceleration that points towards the center of that curvature path, so down to here. That means the net force must also point down that way. We know the car at that moment would be experiencing a force of gravity downwards and a normal force upwards. In order to have the net force point down, mg has to be bigger than the normal force in this case. If we were to write out our equation that represented the net force in the radial direction, there's two ways to go about it. I typically call towards the center of the circle the positive direction. So mg is towards the center of the circle. The normal force is outwards. And that would equal the mass times that centripetal acceleration. If you want to keep our traditional Cartesian coordinate system, where up is positive and down is negative, that's fine. You can totally say the normal force minus mg, but you will need to remember to put a negative sign on for the acceleration, because we do know it points downwards. So we need to account for that direction. So I hope you're seeing similar approaches, a new concept in terms of having forces and acceleration point towards the center of this curve. But net force still has to equal mass times acceleration. Acceleration is still a consequence of having a net force.